Now we'll discuss what is random variable. So in the previous topics and all, we have discussed that we are conducting an experiment, and the outcomes, all possible outcomes of experiment are called the sample spaces or no. And we also discussed that there are some even the outcomes of interest. Okay, so that we define it as event. Okay, so for example, when you are throwing a die, when we are throwing a die, the possible outcomes are 1, 2, 3, 4, 5, 6. Okay, these are the possible outcomes. So this is called the sample space. Okay, and for example, what is the event here? We are interested with only particular outcome. Say for example, we are interested with the outcome which is whose output is less than or equal to 3. Okay, so the what is the event here is, it is having only the outcomes whose value is less than or equal to 3. This is called event. Okay, so what is here, the event will give you the characteristics of the experiment. So it will be, experiment will have only the outcomes. Okay, so what is event? The concept of event will describe the characteristic of experiment. Okay, and also the events will also give us the properties of the experiment. So we can say that, so we have the values less than or equal to 3, less greater than or equal to 3, like that. We, it is also gives the properties of the experiment. Okay, so that is the importance of the event. Okay, so here what we do, we'll be assigning some numerical value to the event. Okay, in this particular concept we'll be assigning the value numericals to the event. Okay, this is, we are assigning in the form of random in nature. Okay, so that is why this is very important to obtain the solution of practical probabilistic problems. Okay, so here if you see that the in real time we'll be having all the signals are in probabilistic in nature. Okay, so to obtain the solution of practical probabilistic manner, we have to give some numerical value to the event. Okay, so that we are assigning in the form of a random in nature. So that is the thing we are going to discuss in this particular topic. So here what is that we are discuss, we discuss about random variable. What is random variable here is, we'll be assigning a real will be assigning a number. Okay, to every outcome of every outcome in the sample space. Okay, so what is random variable here? It is a real function of the elements of sample space. Okay, so here what is that we do, we define the random variable by capital letters, and the elements will be having the values, the values we denote with the lower letters here. Okay, so for example, we are conducting an experiment, we got the all possible outcomes that we denoted in the sample space. Yes, capital S is used to represent the sample space with the elements small s. Okay, so small s are the elements in the um, sample space. Okay, so what is that we do here, we assign a real number to the uh, each and every outcome in the sample space. Okay, so that assignment we have done by using x of s. Okay, so this x of s is called random variable. Okay, so while assigning here to numerical to the outcome of a sample space, we will be using some rules. Okay, so this x of s is called random variable. Okay, so what is random variable? Random variable will be considered to be a function that maps all the elements of the sample space into the point on the real line. Okay, so what happens, you'll be having some outcomes, all outcomes will be mapped to the points on the real line. Okay, so that is called random variable. Okay, so for example, here we are tossing a coin and throwing a die, both we are doing at a time. Okay, so for example, here you see the random variable be a function x is chosen such that a coin head outcome corresponds to positive value of x, and that the value equal to the number that shown upon the die. Okay, so Whenever we are getting head, what is that? It is corresponds to positive values. And what is the value you get? That value is equal to what is the number you are getting on the die. And similarly, so when you get a tail, when we because we are throwing coin and die both, no, when we get a tail, then it corresponds to negative value. Okay, and what is the value here? The value will be equal to twice the number shown on the die. Okay, whatever number we are getting on the die, twice of that will be the value. So what are the possible outcomes? We will be getting head, and since we are throwing a die values are 1 to 6. Okay, so when you get a when you throw a coin, what is that outcomes will be getting? Head and tail, yes or no? So what are the possible outcomes here? You check here, we'll be having totally 12 outcomes. Okay, so what is that function defined here? We have discussed that the random variable is a function of the sample space. Okay, so what is the function defined? The function is defined such that if you are getting head, means it corresponds to positive values. If you are getting tail, means it is corresponds to negative values. Okay, so what is the value here is the whatever value is displayed on the die for positive values, and for negative values, what is the value here is the value equal to twice the value displayed on the die. Okay, so here if you observe this mapping, whenever we get here head, it is corresponds to all positive values. Okay, so if you are getting 1, here also 1, 2, 2, like that. Okay, so this particular outcome, so what are the possible outcomes here? Totally 12 outcomes. Okay, so it is mapped to the 12 values. Here you check it here, this value is mapped to some value on the real line. Okay, so here you check, it is corresponds to some value on the real line. So this process you observe here, this process is called what? This process is called the random variable. Okay, so head is correspond h comma 1 corresponds to 1, h comma 2 corresponds to 2, h comma 3 corresponds to 3, like this here on the positive side. On negative side, whenever we get tail, it corresponds to negative values, and whatever value you get here, it is twice of that value it is mapped to. So here you are getting 1, no, it is mapped to -2. Okay, if it is 2, it is mapped to -4. If it is 3 here, it is mapped to -6. Like that, the value is mapped to twice of the value displayed on the die. Okay, so what is random variable? Random variable will map the outcomes of the sample space onto the real axis. Okay, so that is called random variable. So what is that you get? For every outcome, we are getting some value. See here, for every outcome, we are getting some value. This is called random variable. So we are assigning some numerical values to the outcomes. Okay. So now we'll discuss what is the condition for a function to be a random variable. What is the first condition here is the random variable should be always not multi-valued, means it should be always single valued. That is, so the random variable means what? It will be mapping every point in the S-plane is mapped to the value on the real axis, yes or no? So whenever we are mapping every point on the S-plane to the real axis, it should be mapped to only one value. It should not be mapped to two values. That is like this. For example, our sample space is having the outcome, so 1, 2, 3, 4, 5, 6. This is the sample space. We are getting the outcomes. Okay. Now, for example, it is we are mapping a 1 to only, it should be mapped to only one value. For example, we have a mapped to 2 here. 2 is mapped to 4. 3 is mapped to 6, means we are taking 2 times of this. Okay, like that. It should not, one should not map to two values, that is it should not map to 1 comma 2. So like this it should not mapped. Okay, so it should be mapped to only one value. Okay, so it can also map to the same value. Here 4 can map to the value 2, but there is no problem. But 4 should not be mapped to two values. Okay, so then it is called single valued. Okay, if it is mapped to two values, then it is called multi-valued. So what is the condition here? the random variable should be single valued function. Okay, now what are the other two conditions here is, the first one is x is less than or equal to x, be an event, shall be an event for any real value number x. Okay, this corresponds to those values s in the sample space. What happens, how you got x less than or equal to x? This we got by from the values in the sample space. Okay, so it means that how many number of elements you have in S, the same number of elements you have in X of S. Okay, so X of S does not exceed the number X. Okay, what is X here? Number of elements in the sample space. Okay, so X of S does not exceed the number of elements in X. Okay, so the second condition is that we won't be having x is equal to infinity. Do you have any event with x is equal to infinity and x is equal to minus infinity? We don't have any events with x is equal to infinity and x is equal to minus infinity. So the probability of x is equal to minus infinity and x is equal to infinity should be equal to 0. Okay, so this condition does not prevent x from either. It means that x can vary from minus infinity to plus infinity. Only thing that the event x is equal to infinity, x is equal to minus infinity does not exist. Yes or no? So that is why, what is the probability of x is equal to minus infinity will be 0. Probability of x is equal to infinity will be 0. Okay, so these are the three conditions. What is the first condition is that the random variable should be single valued function. The second condition is that the number of elements in the sample space is x. For example, it is x. Okay, so then the number of elements in the random variable should be less than or equal to x only. Okay, it should not exceed that values. Okay, so then the third condition is that the event x is equal to minus infinity, x is equal to infinity does not exist. That is why probability of x is equal to minus infinity and probability of x is equal to infinity will be 0. Okay, so these are the three conditions it has to satisfy. Okay, now we'll discuss what is the continuous and discrete random variable. Okay, so the discrete random variable is having only the discrete values like this. X of s is equal to, it is having only the discrete value. Okay, means we have one-to-one correspondence with the integers. We can able to count the number of values in the random variable. Then it is called discrete random variable. Okay, so what is the sample space for this discrete random variable? Because we know that the outcomes of the sample space is mapped put to the real numbers, that is why we are getting the random variable. So what is the input for this is the sample spaces or no? So the sample space for discrete random variable can be discrete, continuous, or even a mixture of these two. That is discrete and continuous. Okay. How do you get discrete random variable? The discrete random variable can be obtained from discrete sample space or continuous sample space, or we can have mixture of both discrete and continuous sample space. Okay. Now, for example, here you take the wheel of chance. Wheel of chance is having the value 0 less than s less than or equal to 12. So what type of sample space it is? It is continuous sample space. See here, if the sample space is defined in this manner, so what type of method of representation it is? It is rule based method of representation. If you use rule based method of representation for a sample space, then it is called continuous, ma'am. Okay, so here it is continuous sample space, whereas s value is varying from 0 to 12. Okay, if the value of s is between 0 and 6, if the value of s is between 0 and 6, we'll be assigning value 1. If the value of s is between 6 and 12, we'll be assigning minus 1. So what is our sample random variable? Random variable will have only two values, 1 and minus 1. Okay, so 1 is for 0 less than s less than or equal to 6, and minus 1 is for 6 less than s less than or equal to 12. Okay, so here what is that we have done? We have used the continuous sample space to obtain the discrete random variable. See here, it is discrete, no? So it is discrete random variable. Okay, So that is why to obtain a discrete random variable, we can use continuous sample space, or we can also use discrete sample space, or we can also use mixture of those two. Okay. Now we'll discuss what is continuous random variable. The continuous random variable will have continuous range of values. Okay. So it cannot be produced from discrete sample space. So just now we have discussed that the discrete sample space can be produced, discrete random variable can be produced from both continuous and discrete, yes or no? But here continuous random variable can be produced only from continuous sample space. It cannot be produced from discrete sample space. Okay. So that is why here you see here, because all random variables be single valued function of all sample space points. Why we are getting why we are using continuous sample space for continuous random variable? Because it is single valued function. Now what is random variable? It is single valued function. That is why for to obtain continuous random variable, we have to use continuous sample space only. Okay. And we can also use, we cannot use mixed of sample space also. Okay. For example, this is the example for continuous random variable. Okay. So what is your sample space? The sample space is having the values s less 0 less than s less than or equal to 12. Okay. So what is that the random variable is defined? The random variable x of s is defined as s square. Okay. Every value of s is squared. So what is your x of s now? X of s will be equal to 0 less than x less than or equal to 144. Okay. So this is the continuous random variable. Now we'll be having mixed random variable. What is mixed random variable? It will be having both continuous random variable as well as some of the elements are continuous and some of the elements are in discrete in nature. Okay. So this mixed random variables are very least important type of random variable. In most of the cases we don't use them. Okay. Only in some practical practical situations we will be getting this type of random variable. Okay. So these are the three types of random variables. What are the three types of random variables? Continuous random variable, discrete random variable, mixed random variable. To obtain continuous random variable, we have to use continuous sample space only. To obtain discrete random variable, we can use both continuous, discrete, or mixture of both continuous and discrete. Okay. Whereas mixed random variable will be having very least important. Here some of the elements are of continuous type and some of the elements are of discrete type.